Recently, German Chancellor Scholz made a statement saying that Europe should not be afraid of China's new energy vehicles. He expressed that rather than fearing this challenge, they should embrace it and be inspired. However, it's hard to say if China will win the battle for new energy vehicles, as it is a complex and evolving industry. Chancellor Scholz mentioned that 20 years ago, the seed was planted for China's dominance in the industry. He highlighted the example of Nokia, a European brand that was once the top mobile phone manufacturer. However, with the rise of smartphones, particularly those manufactured in China, the industry landscape shifted. China became a major player in exporting electronic and information products, including smartphones. This laid the foundation for China's current position in the new energy vehicle industry. According to Chancellor Scholz, in the next 10 to 20 years, Chinese new energy vehicle brands will rise globally and become the largest export category for China. He believes this is inevitable due to the improvements in the quality, comfort, and overall experience of Chinese-made vehicles. Chancellor Scholz also emphasized that the manufacturing aspect of new energy vehicles, which accounts for 40 to 50% of the industry, plays to China's strengths in the electronics industry. He compared the future dominance of Chinese new energy vehicles to the success of Chinese smartphone brands like BYD, Great Wall, and NIO. It's important to note that this perspective reflects Chancellor Scholz's view, and the future of the global new energy vehicle market remains uncertain. The competition in the industry involves various factors such as technological advancements, market demand, and government policies. Ultimately, it will be determined by the collective efforts and strategies of countries and companies involved. After the reform and opening up policy, China began to introduce advanced foreign technologies and exchange them for market access. Joint ventures such as SAIC Volkswagen, Chang'an Ford, GAC Peugeot, and Beijing Hyundai were established, and foreign brands almost dominated the Chinese market. China's automotive industry became the largest in the world through the assembly of imported components, but in the entire automotive value chain, China struggled to earn profits, with foreign automakers acting as significant profit extractors from the Chinese market. The fate of China's automotive industry and Chinese industrial development depended on a significant opportunity to overturn the disadvantages accumulated over the past century. In 1992, after Chen Shuisan stepped back from his front line in national defense, he personally wrote a letter to the central government in August. In the letter, he urgently stated that China's automotive industry should bypass the gasoline and diesel phases and directly enter the stage of reducing environmental pollution through new energy sources. At that time, the United States, Japan, and Western Europe were all organizing their technological forces to develop advanced battery technologies. Given this situation, Chen Shuisan insisted that China should not wait any longer. In 1991, the state had already classified the electric vehicle research program as one of the 85 national key scientific and technological projects. In the response letter to Chen Shuisan, then Vice Premier Zhu Jiahua provided a detailed introduction. These two letters essentially confirmed the initial vision of China's top-level leaders for new energy vehicles and the future of the automotive industry. Decades have passed since then. What is the current situation of China's new energy vehicle industry? One can say that everything is in place, only lacking the final push. China has the technology, the market, and the necessary financial and policy support. So, what is missing? The new energy vehicle industry chain is extensive. The above discussion focused on downstream vehicle manufacturing, while the real determinants of the development of the new energy industry lie in the midstream and upstream sectors. The upstream sector involves raw materials, including lithium resources, rare earth magnets, and lithium battery materials. Major suppliers of positive electrode materials include Hunyingui, Beijing Eastspring, and Capcham. Negative electrode materials are mainly supplied by BTR New Energy Materials, Shanshan, and Puliad. Electrolyte suppliers include Tinsy Materials, Shida Xinghua, and XZBQ Corporation. Separator suppliers include Entech, Xingyuan Materials, and more. Structural component suppliers include KDL, Genu Technology, and others. The midstream sector includes key components such as power lithium batteries, electric motors, electronic controls, and vehicle body molds. Major suppliers in the automotive battery industry include CATL, BYD, and Innovation Works. The main suppliers of electronic controls are Huachuan Technology, Wanxiang Ocean Energy, and Blue Sea Huoteng, while major suppliers of electric motors are Shanghai Magnetic Materials, FDM, and Dayang Motor. Currently, the three core components of new energy vehicles, namely batteries, electric drive motors, and motor controllers, account for 40% to 50%, 5% to 10%, and 5% to 10% of the total cost respectively. Batteries alone account for half of the cost, which is more than double the combined cost of the other two core components. So how did the conflict between Tesla and Panasonic arise? It was because Panasonic insisted on high prices, forcing Tesla to seek a partnership with CATL. Initially, Tesla did not possess its own battery technology, and its earliest lithium battery supplier was Panasonic. In reality, this is not meant to criticize Tesla. In the list of the top 10 global power battery suppliers in 2022, not a single one is from the United States. The collaboration between Tesla and Panasonic was actually a necessity. Both Tesla and Apple follow similar models, relying on external supply chains for manufacturing cars. Who could have expected that when Model 3 production was ramping up in 2017, Panasonic walked away? Musk repeatedly called for lower battery prices, but Panasonic, being a giant in the battery industry, refused to budge and insisted on a larger share of the profits. As a result, after signing the agreement for the construction of the Shanghai Gigafactory, Musk secretly met with Zheng Yuchuan, the founder of CATL. Although news of their meeting was kept private, some people calculated that if Tesla were to use CATL batteries, it could reduce the cost of each Tesla vehicle by $6,000 to $12,000. This is not a small amount of money. Subsequently, the speculation from the outside world was proven true when CATL officially became a supplier of power batteries for Tesla in 2020, causing its stock price to soar. So, don't listen to those Americans boasting about foreign-made batteries or the impressive range of Tesla vehicles. In reality, Tesla is using our own batteries. The mileage of a Chinese new energy vehicle is primarily determined by the market, not the technology. If we want domestically produced new energy vehicles to compete with Tesla, which costs hundreds of thousands of dollars per vehicle, it won't be that easy. Battery technology is crucial, regardless of whether it is lithium iron phosphate, ternary lithium, or future solid-state batteries, all of them rely on lithium. Each new energy vehicle consumes an average of 40 to 50 kilograms of lithium carbonate as a raw material for the battery. While our lithium reserves rank fourth globally, our extractable resources only account for 7% of the total reserves, and China's nickel reserves, which are necessary for ternary lithium batteries, only account for 3%. Moreover, most of our lithium mines are located in Qinghai and Tibet, making extraction challenging and costly. The key is that the Chinese new energy industry cannot afford to wait for a wilting vegetable situation. What should we do? We can only move our shovels abroad. Fortunately, China acted early in this regard. With the help of China Investment Corporation, CIC, companies like Rockwood, SQM, and China Tianqi Lithium successfully acquired Talison in Australia and SQM in Chile, two world-leading mining enterprises. Undoubtedly, this process involved a subtle competition between China and the United States. The Greenbushes lithium mine in Australia holds the world's largest and highest quality lithium spodumene resources, and it was controlled by Talison, mentioned earlier. At that time, Talison held about 31% of the global lithium market share and supplied 80% of China's lithium concentrate. China's Tianqi Lithium had already established a cooperative relationship with Talison. However, in 2012, the US company Rockwood suddenly announced a comprehensive acquisition of Talison's common shares. This was undoubtedly a bombshell for China. The US was not using guns this time, they intended to cut off China's path. Once the acquisition succeeded, China's lithium mining and new energy industries would be at the mercy of the Americans. Jian Weiping, the chairman of Tianqi Lithium, was aware of the U.S. company's intent to acquire Talison. He decisively mortgaged all available assets, purchased common shares at a high price, and obtained a 19.99% stake in Talison, quietly becoming the company's second-largest shareholder. Just when Rockwood thought they had the upper hand, Jiang Weiping used his voting rights to veto Rockwood's acquisition proposal. To prevent the United States from making another move, Jiang Weiping prepared to acquire Talison. However, at that time, Tianqi Lithium was not yet the lithium king of China. Its total assets amounted to only $1.569 billion, and its market capitalization was only $3.5 billion. Even if they managed to secure the acquisition of Talison by any means necessary, it would inevitably lead to bankruptcy. Later, considering the new energy strategy, the government decided to use China Investment Corporation to provide funding, helping Tianqi Lithium secure a 100% stake in Talison. This move perfected China's global layout of lithium resources. At the same time, Chinese companies such as Huayu Cobalt, Tianyi Lithium, Ganfeng Lithium, and Xingshan Lithium Energy have continuously established new bases in South America and Africa. The United States has long regarded South America as its backyard. In recent years, they have begun to tighten their policies on mining resources in the region. However, their political influence has greatly declined, and South American countries are becoming less obedient. In the Lithium Triangle, Bolivia and Argentina are unwilling to give up cooperation with China. Bolivia has even rejected the United States and chosen to cooperate with China and Russia in lithium mining. The repercussions of the missteps the United States made in the past are now being retributed globally in the form of rejection. Although China made the first move and established a global layout of lithium resources, the future competition has just begun.